I think we can get started. Good evening, everyone. My name is Mike Schnell. I'm with Southeast Service Cooperative. I am the Community Engagement Coordinator, and it is my pleasure today to be able to introduce you to Sarah Carter, who's the Sarah Carter, who's a STEM Computer Science Integration Specialist from the Minnesota Department of Education for the computer science in the Minnesota Academic Standards session. So thank you, Sarah, for being here. Thank you all for joining us, and take it away.
Great, thanks, Mike. So welcome, thanks for coming to the session. Got a lot of information, but I'm also hoping to have some good conversation as well. And Mike is going to be help me with monitoring the chat in case questions come up. So feel free to type those in the chat. So first, so these are the 10 Minnesota commitments to equity. And in this session, we're really going to focus on these three that I've highlighted. So monitoring implementation of standards, improving conditions for learning, and giving students options. Specifically, the objectives of this session are to understand definitions of computer science and computational thinking, and then specifically to understand how computational thinking and computer science are integrated into the Minnesota academic standards. So just a short agenda. We're going to start by talking a little bit about computer science education in Minnesota, share some common definitions for computer science and computational thinking, talk specifically about what computer science integration is or could be. And then we're going to take a look at some examples from the Minnesota Science and Arts standards of computer science integration. And then depending on how much time we have left, hopefully we'll have some time for discussion. So first, I have a couple of polls that I'd love to just know a little bit about you. So the first poll I think Mike is going to launch for us is I'd like to know what you teach. So go ahead and fill out that poll. If you are an other, you can go ahead and type in the chat. And we'll just give it a little bit for people to respond. And then Mike, once you feel like everybody has kind of responded, if you could just publish the results, that'd be great. All right.
Sharing the results. Can everybody see them?
Yeah, great. So I see high school, and then it looks like, thanks for typing in the chat here. We have somebody from WSU, math instructor, technology, K5 technology specialist, and then my colleague John Olson at MDE as the science specialist. Wonderful. And then the second poll, just to get a little bit more information, is what is your experience with computer science? Oh, yeah, thank you. Thanks. Yeah, if you can just select the option that is the closest to where you currently are. So do you have no experience? Have you taken some coursework or done professional development but not taught it? Have you taught standalone? That should be alone, sorry, not long. Standalone computer science lessons or courses? Have you integrated it into other content areas and a few times, or do you regularly integrate it into content areas? Just give people a little bit to type in their response. Great. Okay, this is helpful. We kind of have people across the board, which is great. That's what I love to see, because then it's really wonderful to have a community where other folks can share with others about things they've done or learned. So wonderful. Thank you so much for participating. So a little bit about computer science in Minnesota. So as I'm sure you've heard or seen, there are states throughout the US that are adopting computer science standards, what I call, or we call, standalone computer science standards. In Minnesota, we don't currently have any standalone computer science standards, and instead are taking a computer science in all approach. And what that means is computer science concepts, practices, and standards are being integrated as the academic standards are being revised. And that has, that's for a couple of reasons. One of them is that many of those states that are adopting computer science standards don't have the same requirements of all students having to reach those standards like we do in Minnesota. So K-5 computer science education kind of varies across the state. It's often championed by a passionate teacher or principal in a building. It sometimes has standalone CS classes taught by either media specialists or specifically computer classes. Some places it's integrated, and then it's also in after-school clubs and activities. In the secondary level, we also are looking at some, also very passionate teachers or principals who make it a priority. So we see it integrated into other content areas. Math is a place we see it integrated in high school quite often. We do see some districts and schools with foundational CS courses. Then we see AP classes, robotics, CTE pathways, all kinds of different things. So when we think about these ideas that kind of get thrown around, these terms, we've got computer science, we've got computational thinking, and we've got coding. And they often are used interchangeably. So just for clarity, when we talk about coding, coding is a technical skill. So this is like programming, and that lives within computer science. Computer science is an academic discipline. And computational thinking is a problem-solving process that is central to computer science, but can also be applied more broadly to problem solving and learning in kind of any discipline. So these words get thrown around a lot. They're often used interchangeably. They are overlapping, but very distinct from each other as well. So starting with computer science, we have this definition from the K-12 computer science framework. So the study of computers and algorithmic processes. I'm going to break this down because this is a kind of word salad. So we're studying computers, the actual thing, and the algorithmic processes, which is essentially kind of the step-by-step thing that makes the computers work. The principles behind computers, hardware and software. So that's the hardware is the design of the physical computer. The software is the design of what makes the computer work. And their implementation, and the implementation of that is that work of computer science. And then their impact on society. So how do computers and hardware and software and all these things impact society? So that is how the K-12 computer science framework defines computer science. We're also going to look at computational thinking. So computational thinking, as I said earlier, is a set of problem-solving skills. It is also a process that's very central to computer science. And I am going to share this presentation, and there's a really good video that kind of defines computational thinking that was put together by Google, who does a lot of Google education, does a lot of work as well. So this is a really good kind of overview. But the other kind of framework I like, this also comes from the K-12 computer science framework. And it lays out a set of practices that are central to computer science. The ones in white are considered computational thinking, and the ones in purple are other practices that are kind of central to computer science. So we see something like recognizing and defining computational problems. So, this is like looking at, look at my notes here. So this is like looking at a problem and trying to figure out whether it's an opportunity to solve this problem with computation, And you can break down that problem into parts and figure out whether a computational solution is appropriate. Then we look at developing and using abstractions. So this is just an abstraction is when you're looking at something and you're reducing it down into the key information that you need. So that's really comes out a lot in computer science. You look at this big problem and you're trying to figure out, okay, I can get rid of all the stuff I don't need. These are the key pieces of information I need. Then you're actually going to go into the creating computational artifacts. And when we look at creating computational artifacts, we also do talk a lot about these artifacts are personally relevant, they're beneficial to the community, they're helping to solve problems. And so when you hear people talking about coding, a lot of the coding happens in this one little bit. So there's a whole bunch of other things that happen, but it's such a small part of CS that we want to make sure to incorporate more than just coding. And then we have testing and refining computational artifacts. So my background is a 5th and 6th grade teacher and doing kind of science professional development. So when I see this, I see a lot of overlap with science and STEM. We're doing testing and refining, trying to figure out what the problem is and what are the parts. We're looking for those connections. And so this is when I think about integration, I like these practices because I think they're really easily pulled over into many other content areas. I'm going to pause for a second and see if I have questions about either computational thinking, computer science questions or comments or other resources that you found helpful to talk about these big overarching ideas.
We do not have any questions in the chat.
Great, thanks. Yeah, feel free if anything comes up or other things that you've used that have been helpful, feel free to type those in the chat. So now I want to talk a little bit about why integrate computer science and computational thinking. So there's a lot of information out there about why it's so important to teach computer science to students. And I'm not going to dive into that. Instead, I'm going to think a little bit about why is this integration one way to achieve some of those goals of teaching students computer science. So for one, when you integrate computational thinking and computer science into other disciplines, it helps you to better understand kind of the computational world. And there are all of these new, programs that students can enter in post-secondary, like computational geology, which is not something that even existed when I was in college 20 years ago. Yeah, 20 years ago. The computation has become such a large part of many different disciplines that this integration in K-12 just allows them to see how it works, in for lack of a better term, in the real world. Also, understanding how computing and programming can influence and shape your world and your life is another really strong reason to do this integration. Computing and programming is all around us. We've seen it with just the huge amount of data we've been getting from COVID cases, and having that kind of understanding about how big data, which is a big part of computer science, works, can help you just understand what's going on around you. And I really like some of these ideas from the K-12 computer science framework. So it allows students to critically engage in public discussion on computer science topics. It helps them develop as learners, users, and creators of computer science knowledge and artifacts. Understanding how these things that we use every day get created and what is the motivation to create them helps them be better consumers and have a better understanding of this world around them. And also, I think I like the last one, I don't want to forget, it does allow you to express yourself and your personal interests in other ways. A good example that I can think of, also one of the benefits of this integration is it often allows students to go deeper into a particular content area. So if you think about using computer science in a geometry classroom, you could have students working in a program called Scratch to program it to draw different geometric shapes. And when they're creating that program, they need to consider inside angles and outside angles and how the number of sides coordinates to the degrees inside that shape. And so it allows them to go even kind of deeper into the content area because of the kind of thinking they might have to do. So this model comes from a researcher named Suchi Grover. She does a lot of research on computer science integration. And this, actually, I've just found this a couple weeks ago, and it's really helping me think about what does it look like to integrate, right? Because this is a big ask. You're asking, earth science teacher to integrate computer science. And what does that look like? Because they don't necessarily have that experience. Well, at the very beginning of them thinking about integrating, it maybe looks like what's all the way on the left, that you're using unplugged activities or you're using simple coding activities to address some of the elements. So you might be using some logic to put together a story in correct sequence. You might code a simple story. Just do some very simple computing. I think that also, it depends on teacher knowledge, but it also depends on student prior knowledge. If you're working with students at the high school level who did not get any computer science elementary or middle school, even though you're tackling really complex, STEM subjects, you still might be doing very simple coding on the far left of this chart. And then as the teacher and the student gets more comfortable, then you can move towards this more complex integration where students are actually writing programs to model and generalize and predict. And I can see so many opportunities to do that in science, in math as well. And then, being able to create new representations that allow for this. You can start using some AI to start seeing how these things can play out. And that, requires, teacher confidence in the content area, and it requires students having prior knowledge. So when we talk about CS integration, I know it can be sometimes intimidating for teachers. We're not talking about starting out all the way on the right with every single activity you do in your program. We're talking about starting out simple and thinking about what are the ideas behind computer science and how can we find links between these computer science ideas and the content that I teach in my, say, earth science, high school earth science class. And then this is a quote that I found in a book that I had sitting right here that I put away. Here it is. So this is a really useful book that is on the last slide of this presentation as well. Computer Science in K-12. And actually each chapter is about a different idea in computer science. The I chapter is about integration. So it is actually alphabetical. And there's some really great both examples of integration in different content areas. But one of the things that she talks about is the really good connection between computing and STEM. We see that in, when you look at the science framework, you see mathematics and computational thinking as one of the practices. And, I think there's just such an easy connection between the two. When you see like the T in STEM, it like, what are you thinking about? Are you thinking about that you're doing stuff on the computer? Are you actually thinking about computer science? So it's just, there's some great connections available. So I'm going to pause again and see if anybody has comments or questions about kind of integration in the kind of big picture. Or, I'd love to hear if folks have experience integrating. What are some things that you've done that have been particularly, interesting or impactful for your students? I think since there are so few of us, I think you're welcome to unmute yourself.
So I have a question that comes up often. When you're trying to integrate something into instruction and you want to use the computer science kind of thing to learn the concepts. In my case, I'm interested in science concepts, but you have a trade-off for the instructional time it takes to teach the technology, the computer science part of it. That's often a prerequisite for actually learning the stuff that you want to do. So, do you have some thoughts about approaches towards that?
I think that's a really great question. And I was going to make a slide of this, but I ended up not doing it. I think, one of the things, some of the barriers to this kind of integration, one is like teacher familiarity with the content. And the other, which I think you're getting at there, John, is like student prior knowledge. If the students don't know how to code, then I also have to teach how to code before I can do this activity that I want to do. And so it does require some trade-offs and some understanding of student prior knowledge. And I think there's a couple of things. One solution is like gigantic, which is, at a district level, if you're integrating from kindergarten on, by the time those students get to high school and they're creating simulations in high school, they have that background knowledge. So that's the long-term plan. And I think the other option is going to require some trade-offs and carving out some time to do stuff within your class. There is, in a little bit, I have some examples of integration. And there's also like different levels of what, say if you're doing a simulation, say you're doing like a simulation on, ecology, like foxes and rabbits, whatever, population dynamics. Do you have those students program that simulation? Well, if they don't have that background knowledge, that's going to take you a really long time and a lot of classroom hours to get those students ready to program that simulation. So maybe the way to do it is to start on the other end and use an existing simulation and have those students ask questions about how that simulation is made. And then, build towards being able to create something similar. So I think it requires trade-off, and until students have a lot of background knowledge, it means that we're not always going to be able to have students create that simulation from scratch, or create code that program from scratch right away. Hope that answered your question. There's not a good answer. Other examples or thoughts or questions folks have about CS integration they'd like to share? Okay. So next I want to talk a little bit about the standards updates. So as I said earlier, we are integrating computer science into all of the academic standards moving forward. And moving forward meetings, we start with art. We started with the arts. So there are CS standards integrated into the art standards, the science standards, and John has a session in the next session, has a presentation in the next session about the new science standards. So go learn about those. English language arts, they just finished and they're currently in the process of rulemaking. They have computer science integrated. Social studies is happening right now. I believe they're working on the first draft. Usually we get to integrating the CS in the second draft. And this is a plug for me to say, even if you are not a social studies teacher, if you have background knowledge on computer science, make sure you take some time to look at that second draft and provide feedback on the CS standards. And then math will come up for review in 21, 22, and we'll be integrating computer science into those as well. So One thing I wanted to mention about this integration. So the Minnesota standards, they tell you that like the content that students should learn. And so sometimes that content has a little CS in it. However, they don't dictate the context. So there are many opportunities to integrate CS in the way you're going to teach a particular standard that is not written into the standards and benchmarks. So that's another thing to consider, that there are many opportunities to integrate CS when you think about the context. And I see, Mark, to answer your question, they are directly called out in the standards. They have an asterisk next to them. I believe the arts standards have one asterisk, and the science standards, I think, have a double asterisk. And the other thing that I'm creating that I'm going to ask for your feedback on, because it's new, is a document that compiles across all the different content areas the CS integrated standards. So that's something new that I'd love your feedback on how helpful that is. So we have some common language. In Minnesota, we have standards and benchmarks. And I think many of us, myself included, use the word standard when we really mean benchmark. So I just want to define these first. So a standard is the summary description of student learning in a required content area. And for, I believe, almost all of our standards right now, it is a big idea that spans several grades. So it either spans K-12 or it maybe spans K-5, depending on the content area. The benchmark is like a step down in hierarchy, where it's the specific knowledge or skill that a student must master to complete part of that academic standard by the end of that grade level or grade band. So when we say the CS is integrated, it is integrated at the benchmark level. Although in science, there is one standard that includes mathematics and computational thinking. All of the rest of them, we're looking at the CS integration at the benchmark level and not at the standard level. So let's move to an example. So this is a second grade example. And even though we're mostly high school teachers here, I think we can still talk about a second grade example. So the Minnesota Science Benchmark, this is one of the physics benchmarks, identify and predict quantitative patterns of the effects of balanced and unbalanced forces on the motion of an object. And then within that benchmark, there's also an example. And then specifically, I highlighted also data displays may include pictographs and bar graphs. So this is an opportunity for you to grab one of the resources. I don't know if everybody had found the resources section.
I will actually post the resources. You can go in and see the resources for all of the speakers, but I will post them here in the chat as well.
Great, thanks, Mike. So two of the resources that'll be helpful for you, well, they're all going to be helpful, but two that are going to be helpful right now is the K-12 computer science standards, and I have it in two different versions. This version is the long version, so there's a standard and a descriptive statement. Then the one that I typically, of course now my little Zoom screen is getting in the way. The one that I like to use is the short version. So this just has the standard. So I find this is a really helpful resource when I'm looking at our standards and looking for, integration. So go back to my PowerPoint for a second. Okay, so we're gonna go back to this. Identify and predict quantitative patterns with the effects of balance and unbalanced forces on the motion of an object. And then we're going to take a look at the CSTA standards. And I don't know if you can see this, if it's too small on your screen, but this first row is ages 5 through 7. So this is essentially K to 2. And when we look at the data and analysis section, one of the standards is to identify and describe patterns in data, such as charts or graphs, to make predictions. So, like, the first thing you notice is that does not include using a computer at all. And that's okay. That's part of computer science. Especially at this grade level, is the particular skills, not necessarily using a computer. So the connections to computer science here are looking at abstractions and data analysis, and then looking for these patterns in data visualizations to make predictions. So when you think about how do I integrate CS in this, really you could just have a conversation, just doing this benchmark, bundled with a couple others related to physical science, you're covering computer science without really having to do a whole lot extra. So I think that is an example that I find very useful. I also pulled an example from the arts standards. So this is one that is identified in the arts standard. This benchmark is compare and contrast how creating and presenting media artworks forms personal and digital identity. And this is a 5th grade standard. And 5th grade is this second column. And they're within the computer science standards. There's a couple of ways to connect it. One is thinking about how personal information can be protected. So if you're putting out your artwork onto the computer, onto the internet, you need to pay attention to how your personal information is going to be protected. That's something we definitely want students at this grade level to be to understand. And then the other spot, now let me see if I can find it again. Lost it. There it is. Okay. There's also a standard here in the 6th through 8th grade that is compare trade-offs associated with computing technologies that affect people's everyday activities and career options. So I think this is another good example of how, when you're doing computer science integration, you're not just doing programming. And then I believe I have one more. Okay, here is one from science, 9th through 12th grade. So this is develop a data simulation based on observations and experimental data of how the pressure, volume, temperature, and mass of gas are related to each other to predict the effect on a system of changing one of those variables. And when I look at the high school standards, which is really this last column, one of the connections is creating interactive data visualizations using software tools to help others better understand real world phenomena. There's also one around creating computational models that represent the relationships among different elements of data collected from a phenomenon or process. So it's right in there. I mean, there's so many good connections to science in these CSTA standards. Let me put the slide up again.
I don't know if you saw John's question here, but I think that it is relevant at the spot that we're in. Okay. In Minnesota, is there a computer science course that students are required to take to graduate from high school?
No, computer science is not required for graduation in high school in Minnesota. You can take, so a math course may, sorry, do the other way around. A CS course may count as a math requirement for graduation, but it has to meet the math standards. So there is no CS course requirement to graduate from high school. And then this is the chart I was talking about from earlier. So this is a kind of a progression of computational modeling in STEM. So when you look at the far left, it's just understanding the variables, playing with existing simulations. And that is kind of foundational to be able to create your own model. So if students have no experience in creating models and simulations, really, you know, the first kind of interactions you want them to have is playing with existing simulations. But they have to go one step deeper than just playing with them. They have to have an opportunity to identify the variables. And then the next kind of step over is, you know, understanding how the system is set up, then looking at some of the relationships and how they're connected. Then once you have a lot of experience with that, then students move into creating their own model. So this is another way to think about, like, if your students have never created a model before, probably not best to, you know, ask them to create a super complicated model to look at the way that, I can't think of anything right now, gases behave in a vacuum. How's that? So kind of I think we have about, my watch, 8 or so minutes left. I did want to have an opportunity to just hear a little bit from you all about what you're thinking about CS integration. And here's some resources. I'll put the resources up on the screen. So we'd love to see something in the chat, or feel free to unmute yourself about ways that you know, you have integrated CS, or some, you know, examples that you've used, or questions you have specific to kind of integration, or you know, what we're doing in Minnesota currently.
I guess my question is, what languages, what programs are you kind of recommending for us to use? I mean, I think, like, there's a lot of programs that have a pretty steep learning curve, and getting the students to have computational thinking in CS in a short period of time, like John was saying, is that learning curve is so high. What are you recommending we use to overcome that?
That is a good question. There are so many out there. And, you know, I think I don't have a really specific answer. I don't have an answer for you that's as specific as I'm sure you want, because I'm going to say it depends on your goal. So there's some great resources out there. I think Scratch is a really wonderful resource, even for high school students. It's block-based code. It's really easy to pick up and code something. I think there's some really great resources out there with a program called Bootstrap that is a fairly, you know, low floor of entry to understand how to, you know, create a program. There's another one that I'm thinking of right now, but it's not coming to the top of my head. It used to be in New Mexico. Sorry, I'm not thinking of it right now. But that one is really good for creating simulations, and is a fairly low barrier to entry as well. I think some of the resources here, the CS distance learning resources link, and I will share this so it gets up on the presentation, so it gets up on the resource page. This has quite a lot of resources, which, let me see if I can, pulled together by the Minnesota Codes group, MN Codes group. And they have kind of a whole bunch of different topics. So coding platforms, coding projects and platforms. There's some good examples here. Google CS First is a pretty good one for middle school students. So there's just so many out there that it really depends on what your goals are. What kind of goals you're looking for. Does anybody else have some, recommendations of things they've used? The other thing I would say is take a look at this computational thinking and coding for every student. I believe she also it's also digital, but in the integration chapter, she has some really good examples. Maybe even I can find the one that I was thinking of across different content areas. Let's see, it's usually in science. Yeah, it's just not coming to me right now. Sorry. Any other questions or comments to share about kind of integration, your experiences?
Do you know if there's any districts that are doing replacement math courses like you had talked about? So replacing like an entire algebra, geometry, advanced algebra curriculum with a computer science option that would lead them through?
There's one in particular, I don't know that the whole district is doing it, but there's one teacher in particular that I can think of who was doing that in geometry and algebra, maybe. And I don't have his name off the top, his contact information off the top of my head, but if you're interested, I'm sure he would be happy to make the connection because he's created some resources for integration in math. And is looking for more teachers to work with. So I do have my contact info at the end here, so feel free to reach out and I can connect you with him. He's done a lot of work with that, and I believe, somewhere in central Minnesota. I can't remember the district, it was at the tip of my tongue. Other questions or? I have another question for you all before you leave. So I am working on this document that is an integrated, it'll just include the computer science benchmarks for each content area. My first question, and you feel free to enter it in the chat or unmute yourself, would this be useful? So it would be a document that would include the benchmarks across the Minnesota content areas, but just the computer science integrated benchmarks. Is that something that would be useful for you? Is my first question. I see one yes. That's helpful. At least have one person because I'm starting to work on it. And then the other thing I was thinking about is both for, so in K through 6, it would be organized by grade level. So it would have all of the kindergarten. So it would have kindergarten arts, kindergarten science, kindergarten social studies, kindergarten ELA, because usually that is like one person who, usually at the K6 level, you only care about a particular grade level at a time. Even if you're, somebody teaching all the grade levels in a school, you're still like this, during this time I'm teaching kindergarten. And at the high school level, it would be organized by content area. Middle, so 6 through 12, it would be organized by content area. So it would be, arts, and then it would be earth science, physical science, then it would be the, can't think of the other ones right now. ELA would be English language arts. I agree, Mark. I think, a lot of the work that we're trying to do statewide is, working with stakeholders to, talk about the importance of CS and think about as a state, what kind of support do we want to create for students around CS. So I appreciate your time. I do realize it is, I think I'm at the end of my time, so the new session is starting soon. I will be back in the main room if you have any further questions or want to have a conversation. But thank you all for attending.
Thank you so much.
Yep, thank you.
Great information and highly appreciated.